So hopefully we know what a scatter plot is. Okay, so we'll just start with a definition. So a scatter plot this is a graph with points plotted that shows a correlation between two sets of data. So a scatter plot is a graph with points plotted that shows a correlation between two sets of data. Okay, and it's exactly what it says. It's just data scattered all over, depending on two sets of data. Okay, um, it could be, I don't know, days of the week and hours worked or something, or a bunch of different things or different elements that you might have. Okay, so when we have a scatter plot, there's some information that we need to look for. Okay, um, so what you'll be looking for is you'll be looking for clusters. All right, so what clusters are? These clusters, this is a set of closely grouped data. So it's just kind of like when you hear somebody say a cluster of people, it means there's just a bunch of people that are gathered around, kind of close together. And this will all make sense once we're going to draw like kind of a scatter plot example here in just a second. But I want to get the definitions out of the way first, so we have that. And then the last one is an outlier. And the word outlier, you can kind of think about outsider. Okay, this is a data point that is outside of the rest of the data set. Okay, so an outlier, you can kind of think of outsider. If you saw a group of people, like if you guys were sitting on the bleachers, okay, and say everybody was kind of sitting in the middle of the bleachers, and there was like a random person sitting way up in the far right corner, they would be considered an outlier because they're kind of up there by themselves. They weren't around the rest of kind of the population. So we're going to draw an example data set here. And I'm going to circle our outliers and our clusters so we can visually see what those look like. So we'll say we'll count by fives. And we'll do the same here. And we'll say these are shots, as in basketball, attempted, and shots made would be over here. Let me turn this sideways. All right. So now me, mine, I'm going to be way up here. I'm going to be 30 for 30. That's going to be me. Okay. So we'll put my Mr. Reed's data set up here. All right. 30 for 30. That's what I'm talking about. And then you might have, random groups of data. Just kind of say we did each player throughout the season or something. Okay. Just kind of all in this little data set here. Now, if I was to look at this data, I would consider this to be a cluster of data. Okay. All of this is grouped together. So this would be your cluster. All right, this is the main part of the data. How do I know it's the main part of the data? Well, it's a huge group of the data that is all kind of together. Okay. This part of the data is going to be your outlier. Because if I was to look at this data without knowing anything, if I just gave you this chart without any numbers on it, you could look at that chart and determine, oh, well, this one's kind of way off here by itself. So I don't know what's going on up here. But all this seems to be kind of your cluster is kind of like your average, I guess you could say, of the data. The outlier is what's going to skew any of this data. All right. So that's like, if we stick to the basketball premise, say somebody they played 30 games, and out of those 30 games, 29 of the games they score less than 7 points. All right. But they have one game where they have 30. That 30-point game is going to say it's going to shoot their average way up compared to the rest of the data. All right. They're kind of like your grades. Okay. You get hundreds on everything, but you get a 0 on a common assessment. All right, that one outlier can really affect your grade. It doesn't show exactly what you do, but it really, really affects your grade. Okay, so we would consider that an outlier. It's just kind of out there by itself. So if I ask you to interpret this data, you should be able to look at this data and give me some sort of information about this data without knowing anything. You should be able to point out this is an outlier. This will really affect this data. Most of the team is kind of right in here. Okay. So something else that we need to look at. So you might be thinking, well, how does this kind of relate to what we've been working on, slopes and slope intercept form and point slope and everything? Well, if you get this data, you need to be able to make predictions. Okay, and what I mean by predictions is if I said, okay, how many shots would the team make if they had 25 attempts? Well, you should be able to predict that just by looking at this. Okay, so we can look at this, and now what we can do is we can make up some sort of data to predict the future of what could happen based on what we know. All right, so what that's called it's called a trend line. So you have a trend line, and this trend line is kind of your approximate formula for your cluster of data. Okay. So a trend line, this is an equation that comes as close as possible to the points on a scatter plot. Okay, so your trend line, this is an equation that comes as close as possible to the points on a scatter plot. Now we are going to be the ones that find this trend line. Okay, so what you're going to do is you're going to look at this data, all right, and we're going to kind of try to figure out, okay, there's a line, how's it going to go through the center of this data? Okay, what's going to happen here? Where is this a positive correlation, negative correlation? What is going on? We know this is a positive correlation because this is going up. Okay, my cluster looks like it's kind of traveling upward. All right, so what I'm going to do, let's say we're going to pick random points. Okay, so let me write my steps here. So if we're finding a trend line, step 1, we're going to choose 2 points. Okay, one on the lower end and one on the upper end. Now in our trend line, we don't want to say, oh, one here and one here, because this is going to make a line that kind of goes below the data. We want to find 2 points that create a line as close as possible to the middle of this data, ignoring any outliers. Your outliers will skew your data. So let's say I choose this point. Okay, there's one. let's say that point is, I don't know, 5, we'll say it's 5, 7. Okay, so my lower end point here will be 5, comma 7. And I know this line might run kind of through the middle here. So we'll say we choose this one here. It's going to go, that's pretty close. So we'll say this is 2417. Okay. And what you would do next, step 2, we would use the 2 points to write a slope intercept form equation. Okay. And how do we do that? Well, first we would find our slope between these 2 points. Okay. And then once we find our slope, then we would find our y-intercept. All right. And that will give us our slope intercept form equation. And we've done that before. All right. So I won't really go through that. But you use these points, label them, find your slope, and then use our proper steps to find our y-intercept to plug them into our slope intercept form equation.